In this video, we are going to see about first generation computer. The period of first generation computer was in 1940 to 1956 using vacuum tubes. Hardware technology. First generation of computers started using vacuum tubes as the basic components for memory and circuitry for CPU, that is Central Processing Unit. The input to the computer was through punched cards and paper tapes. The output was displayed as printouts. Software technology. The instructions were written in machine language with uses zeros and ones for coding of the instructions. Physical appearance. These computers were large in size and required a large room for installation. Examples: EDVAC, that is Electronic Discrete Variable Automatic Computer. EDSAC, that is Electronic Delay Storage Automatic Calculator. UNIVAC, that is Universal Automatic Computer. ENIAC, that is Electronic Numerical Integrator and Computer. In this video, we are going to see about second generation computer. The period of second generation computer was in 1956 to 1963 using transistors. Hardware technology. Transistors replaced the vacuum tubes of the first generation of computers. During this generation, using the transistor were cheaper, consumed less power, more compact in size, more reliable, and faster than the first generation machines. The transistors were far superior to the vacuum tube. Compared to the first generation, these computers were smaller, faster, and energy efficient. In this generation, magnetic cores were used as primary memory. The magic tape and magnetic disk were used as secondary memory. The second generation computers still relied on punched cards and printouts for outputs. They used the concept of a stored program, where instructions were stored in the memory of computer. Computing characteristics. The computation time was in microseconds. Software technology. The instructions were written using the assembly language. Assembly language used mnemonics like add for addition and sub for subtraction for coding of the instructions. Assembly language is easier than the machine language. High-level programming languages such as COBOL and Fortran were also developed during this period. The first computer of second generation was developed for the atomic energy industry. Physical appearance. Transistors are smaller in size compared to vacuum tubes, so the size of the computer was also reduced.
Computer. The period of third generation was 1964 to 1971 using integrated circuits, that is ICs. Hardware technology. The third generation computers used the integrated circuits, that is IC chips. In an IC chip, multiple transistors are placed on a silicon chip. Silicon is a type of semiconductor. The use of IC chip increased the speed and efficiency of computers. The keyboard and monitor were used instead of the punched cards and printouts. Software technology. In this generation, remote processing, time sharing, real-time, multi-programming operating system OS were used. Operating system allowed different applications to run at the same time. High-level languages were used mostly for programming instead of machine language and assembly language. Computing characteristics. The computation time was in nanoseconds, that is 10⁻⁹ seconds. Physical appearance. The size of these computers was quite small compared to the second generation computers. Examples: NCR 395, IBM 360, IBM 370, PDP 11. Fourth generation computer. The period of the fourth generation was 1931 to present, using large-scale integration LSI and very large-scale integration VLSI circuits. Hardware technology. The technology used is large-scale integration LSI and very large-scale integration VLSI circuits. Thousands of transistors are integrated on a small silicon chip using LSI technology. Microprocessor is a chip containing millions of transistors and components designed using LSI and VLSI technology. Semiconductor memory replaced the earlier magnetic core memory, resulting in faster access to storage. Secondary storage device like magnetic disk became smaller in physical size and larger in capacity. The linking or networking of computers is another key development of this era. Software technology. Several new operating systems like the MS-DOS and MS Windows developed during this time. This generation of computers supported graphical user interface, that is GUI. The GUI is a user-friendly interface that allows user to interact with a computer via menus and icons. High-level programming languages are used for writing programs. Physical appearance. They are smaller than the computers of the previous generation. Some can even fit into the palm of the hand. Examples: Intel 4004 chip was the first microprocessor. In 1984, Apple introduced the Macintosh. Disadvantage: the latest technology and highly skilled staffs are required for manufacturing of microprocessors, so it is difficult to build. Applications. They became widely available for commercial purposes like billing and computing machines. Computers became more powerful. They could be linked together to form networks, which eventually led to the development of the internet usage. Fifth generation computer. The period of fifth generation is present and beyond date using ultra-large-scale integration ULSI. Recent research has focused on developing the thinking computers, that is artificial intelligence AI. This generation is based on parallel processing hardware and AI, artificial intelligence software. Hardware technology. The VLSI technology became ULSI, that is ultra-large-scale integration technology, which enabled to store millions of components on a single chip. Software technology. AI, that is artificial intelligence software, which includes areas like expert system ES, natural language processing NLP, speech recognition, voice recognition, robotics, etc. All the high-level languages like C and C++, Java, .NET, etc. are used in this generation. Examples: robot. Applications. This generation of computers uses parallel processing that allows several instructions to be executed in parallel, thus results in faster processing speed. The Intel Dual Core microprocessor uses parallel processing, mainly used for high-level scientific applications in the areas of space research and defense.